recording, just so you know. Back to the ever-present Carl Friedrich Gauss. So arithmetic series are about adding things up. What do we assume he did to sum the numbers from 1 to 100? They kind of mention it in the video, which happens to be an something sequence. The numbers from 1 to 100 we decided was an arithmetic or geometry. Sequence, numbers from 1 to 100, what would the U of 1 be?
1.
Yeah, good. Common difference?
1.
Yeah. And the number of terms?
100.
Yeah. Just practicing decoding what the top positions are asking for. So he added the numbers from 1 to 100. But remember in the video that we watched on the TOK lesson, they kind of mentioned what they think he did. To do it so quickly, what do they...
You should watch it.
What did he get? Yes, Laurie?
They grouped the ones to zeros together, and then they grouped...
Yeah, they grouped them.
Yeah.
And then, yeah, you're right. And then these ones. And then they grouped these ones. What did all those pairs add up to? 101, yeah. And how many pairs in there were there in total?
50.
50, yeah. So that's kind of what he did. So let's just write that out. So he realized there were 50 pairs of 1 plus, 100. Even better. 50 he got from 100 over 2, didn't he? So maybe I should put 100 over 2 at the front, because that's more what the real formula looks like. So he kind of did that, didn't he? 50 pairs of 101. So we can also write the word 50 pairs of 101 if you want. 50 pairs of 101. So that's actually the formula in the formula booklet for calculating the sum of n terms in an arithmetic sequence. So we've naturally kind of like worked out what one of those formulas in the formula booklet is for adding up the terms in an arithmetic sequence. This one relies on you knowing the U of 1, and it relies on you knowing the final term in the sequence. So if you know what the last term in the sequence was, then this is a really easy version of the formula to use. But if you didn't know what the last term of the sequence was, like they said, okay, the sequence is 1, 5, 9, 13, work out the sum of the first 76 terms. You don't want to have to add up to the 76th term. There's a way that you can work out what this is using a formula instead. So I need to first of all write this as a formula, but instead using the symbol, S of n for the sum, so the S of n equals, we need to sub in the U of 1. The U of n just means the nth term, so the 100th term, and n would be the 100 over 2. So the number of terms is how you use to work out how many pairs you've got. So what am I going on about? I'm just basically getting us to write what's in the formula booklet. Write this, but with the symbols in there instead to make the general term. So this 100 came from the fact that there were 100 numbers in the sequence. So that's the n. So n, it's always half of the n. So if you had 76 terms, then you do 76 over 2. So there would be 38 pairs. And then let's sub in the U of 1. U of 1, the first term, plus this thing, they're just the same, meaning like the last term in the sequence. So by U of n in this case, they're referring to it just being the last term in the sequence.
So U of n is the last term of this sequence?
Yeah, that might be worth writing in, actually. Good point. So in this case, we're referring to the U of n as being the last term in the sequence. That's what we mean by the U of n in this case. So that version of the formula is the easiest one you could use. There's 2 versions, but it relies on you knowing what that last term is, and that's a bit of a drag to have to calculate it by hand. But if you don't know what it is, it's not the end of the world. What they do is, remember there's a formula for U of n from lesson 1. Lesson 1, the formula for U of n equals U of 1 plus brackets n minus 1d. The U of n for an arithmetic sequence. They've come up with a second version of this formula, where they've just subbed in the formula for u of n and then collected like terms. So we're going to actually just prove that if you sub in the formula for u of n, collect like terms, you get the second version of the formula, which is in the booklet. So we're about to just generate that ourselves, just so you can see where it comes from. So well done, you've just formulated one version of the sum formula for arithmetic series sequences found in your formula booklet. Notice that the above version, as we said, of the formula requires that you know the value of the last term, which a lot of the time the questions don't give you. But if they do, then you should use this version, because it's fast. Yeah?
Can you explain that further?
Like a gauss? It's like a gauss, but you can also say it like a gauss.
So like a board.
Yeah. So you have just formulated this version of the arithmetic some of the arithmetic sequences like a gauss. So yeah, so we need to be able to see that. So notice, yeah, you can adjust the AC and the doors and everything as you want.
My mum's outside.
Oh, okay, nothing. You can see your mum. So that's okay, we can just, because I'm just chatting about what I just chatted about. So notice that the above version is the formula requires that you know the last term. What if we didn't know this value, u of n? How can we rewrite the above formula, but instead we'll substitute in the general formula for u of n? The general formula for u of n, I'll just write that on the side.
What does SN mean?
Oh, the sum of. Yeah, very good point. Yeah, S of n means the sum of. You might, yeah, so that might be a good idea. Let's write that on the above one as a little code. You're referring to this bit? Yeah, that's it. Yeah, the sum of n terms.
And the U of 1 is the first.
Yeah, u of 1 still refers to the first term, and n refers to the number of terms in the sequence. Like, is it 76 terms they want you to add together?
So
Went forward too far, didn't it? The sum of n terms is that one. U of 1 is the first term, n is how many terms do they want you to add together? Do they want you to add together the first 50 terms, or do they want you to add together the first 900 terms? So rather than you have to do that manually, a shortcut formula has been generated for you that they love you to use in your exams. So what we're going to do is we're going to write a new version of this, but we're instead, imagine if you didn't know what that was, but you could then sub in the formula for u of n. I don't know if you remember the u of n formula from lesson 1 for arithmetic sequences. It's u of 1 plus n minus 1d. So see where it says u of n there? We're going to sub in this instead. And we're going to collect there.
That's a formula to find out the last term.
Yeah, exactly. So that's a formula to find the last term. We're going to sub this formula into the above short version formula and then collect like terms, because you notice when you sub this in, you're going to have to collect like terms in terms of there's going to be two u of 1s added together. And then this is going to stay the same, to be honest. And then in the formula booklet, they give you that second version as well. So all we're doing here is just showing you where that second version comes from. The fact that they're technically still the same two formulas, but it's just one of them has the u of n formula subbed in. Yeah, it's a long formula. I haven't heard, but they were meant to do it this week. I saw Mr. Mello over here last week. Do you want to get some water? You can grab some water. By the time you come here, we will have probably just filled this in. Yeah, so I'm going to just zoom out of here. I'm going to zoom out of here just so you can sort of see the above formula while I'm writing it down here. So we just write, you might want to leave like maybe 2 lines, because we're going to start it just straight away, and then we're going to collect like 2 lines. We can say S of n equals, we've still got our n over 2, n over 2, brackets.
Oh, so we're substituting that equation in for un.
Yeah, exactly. That green stuff we're going to sub in here on our first line.
Okay.
And the second line will just be then when we've collected like terms. The only like terms we're going to collect is that you're going to have a u of 1 plus a u of 1 when you sub it in. Okay, yeah, u of 1 still there? Okay. U of 1 plus, and now I'm going to sub in the green stuff here for u of n. So instead of u of n, I'm going to put this green stuff. U of 1, which is the formula from lesson 1. It's been quite good. And last step, we just collect any like terms.
Yes.
Yeah?
So you're gonna have to put a bracket around the green.
No. Yeah, because you're just adding. Because you're just adding this.
Okay.
Yeah, good point. And then otherwise, if you're multiplying it, then yeah, for sure you'd need a bracket. And this bracket just comes from because there was a bracket there to begin with. So that's why I've kind of got this weird colour coding going on. So that's just to point out that instead of U of n, I've subbed in what U of n represents. And now the last step would be the formula, but just written with the like terms collected. So I'm going to do it all in purple just to show you it's one elegant formula. So sum of n over 2, we can't simplify that or do anything with that. But what can we do with u of 1 plus u of 1?
2u.
Yeah, exactly. 2u1, and then you've still got the plus n minus 1d. And that's the formula in the formula booklet as well. They give you this one, and they give you this one. So to highlight that, I'm going to put a nice yellow thing around it. So these two yellow versions are in your formula booklet. And so the whole point of that was just to point out that these are technically the same formula. It's just that this one has the U of n formula subbed in. It's all right.
Could you also write it as 2u, well, could you write the part with the beginning of it as dn minus d?
Yeah, you could. Yeah, totally, yeah. So the only thing I've done with this one is I've just shown you what's exactly written in the booklet. Yeah, so if you want to do expanding and stuff, you can. Yeah, that would be 2u of 1 plus dn minus d. Yeah, but they only give you that. And the good thing about it, it looks awkward, but if you plug in the numbers, so if you plug in a value for n, a value for u of 1, n and d, and if you type it in like that in your calculator, it calculates it correctly as well. So that's a nice way. That might have been why they argued and decided to present it this way, because when it's plugged into the calculator in that way, it works nicely. It should be the same when you have the d here, but I think maybe it got awkward with the old calculators if d was negative. So that's what I'm wondering. Maybe the old calculator, if d was negative, maybe it went plus negative instead, rather than negative times, and then add that. But your calculators now do BEDMAS pretty well, so but they're just keeping it around for some reason. So congratulations. So you yourselves have just formulated the other version of the sum formula for arithmetic sequences. This tends to be the one you use the most because most questions I've found, they don't give you the last term in the sequence. So we tend to use this one more. But if they give you the last version, this is a nice, super fast way to do it. Imagine if they didn't tell you the D, or they didn't tell you, I know you need the U of 1, don't you? So imagine they didn't tell you the common difference in the question, but they told you the first term and the last term and the number of terms, then this one would have been super fast. You wouldn't need to bother calculating the common difference. So keep that in mind, because I've got a few questions in the examples coming up where I've not given you the common difference, so maybe this version would have been faster. Like I've given you the first and the last term and the n. So keep an eye out for a question that might be like that, because we'll be deciding which formula we're going to use. The most awkward ones could be when they give you the sum, they give you the n, they give you the u of 1, and they want you to solve for d, for example. So there could be, yeah, there can be some awkward kind of algebra solving. Or even worse, they want you to solve for n. That would probably tend to be with calculator though, if they want you to solve for n. So now we need to practice applying these two awesome rules, which are in our formula booklet. So you might want to keep this page, I know you have to write on the back, but you might want to keep this page as a reference when you're doing these. Oh, we're going to write them here anyway. So I knew that you would need them on the next page, so I said let's just write them out again. So the two rules that can be used for the sum of an arithmetic series, we're just writing them again here, just so when you do the problem below you can see the formula above. Just writing them out. The first one was the nice one, n over 2, no, not too mixed one, getting mixed up, that's the long one. You can write the long one first if you want. U of 1 plus u of n. That's a simple version. The more commonly used one is n over 2, 2u1 plus n minus 1 d, and close bracket. So you kind of realize it comes from the formula booklet, so they're super important. Now a whole stack of applications. So numbers are going to be big. So the numbers, the answers to a lot of these are kind of numbers in the thousands or tens of thousands. So definitely feel free to grab out your calculator if you haven't already. I know what the final answers are meant to be, but it's good for you to practice plugging things in quickly if you can. So this would tend to be more calculator kind of stuff. Both rules are in your formula booklet. This one you use when you know the last term in the sequence. This one you use when you don't know the last term in the sequence. Okay, back to here. Now let's apply. Nice easy one. This is what you hope to get in your exam. Find the sum of this sequence if it was 50 terms. That's probably the best one you could get. Where we don't know, do we know the last term? No, we don't know the last term. So we're better off just using this one. I'm a real fan of writing out my lists. I don't know if you're like that. I'm a bit listy. So my favourite thing to do is on the side. It's probably because I'm delaying thinking too much, so I just want to relax a bit, write out these things. View of 1, 4. First of all, they didn't tell you it was arithmetic, but this topic's arithmetic, so we can assume it is. What's our common difference? 3, good, yeah, 3. What's our n? And sometimes I like to write, what do they want? They want the sum. So they want S and N, S of N equals question mark. So I personally find that useful, because when I'm filling it in the formula, I don't have to think as much. And it just gives me something relaxing to do before I start to plug everything in. You don't need to write the formula out. You don't really necessarily always get points for writing the formula out, but if you want to, you can. We've got the formula written above, so if you want, let's go straight to subbing it in. So S of 50, I'm just going to show that you can call the sum of 50 terms, you can write as S of 50. And I'm just going to do that because the question might not have said find the sum, they might have just said find S of 50. So just so that when you go back you can understand what S of 50 means. It means the sum of 50 terms. And then you can just plug in stuff. We need to use the second version because we don't know the last term. So 50 over 2, 2 times u of 1. 4. 2 brackets. 4. So if you want, I'll just do them in colours so you can see what's being subbed in. Something worse than that. It's kind of slow. 2u of 1 plus brackets n minus 1. N is 50. Minus 1. And the common difference is 3. So what's brilliant about that though, is you can put it into the calculator just like that, if you want, and it's going to give you the right answer. There's no need to work out anything first if you don't have the time or can't be bothered. So yeah, your formulas, yeah, feel free, can you jot the AC up?
Yeah.
Yeah, it's good to have a little break in there. And when it gets too hot again, just let me know. So feel free to plug it into a calculator and I'll let you know if you've got it right. It's around the 3,000 mark.
So what again? 875.
Yeah, 3875. So these are the kind of numbers you're going to get when you're working out sums. You're going to get big numbers. Well, it's possible to get big numbers. If your common difference was 0.5, then the numbers aren't going to be necessarily so big. Yep, so don't be surprised if you get big numbers. So that's an awesome question, just a nice straight up one. So you might want to have your little formulas page kind of like on the side as a reference, because remember you'll always have your formula booklet. So then you can decide which formula you want. Find the sum of these ones. Which version of the formula would you use? The short one or the long one, do you think?
The short one.
Yeah, because we know the last term, don't we?
So we don't know the number.
Yeah, we don't know the number. So how did I do this? I'm trying to remember because I haven't written out what my working out was. Oh yeah, we've got to solve for n first. So that's a drag. So this is the nth term. This is the u of n. So we need to use the u of n formula from lesson 1 to solve for n. And then once we've solved for n, so on this side we'll do the solving for n. Then once we've solved for n, we get a nice whole number. And then we just sub it into the sum formula, like the short sum formula. So have maybe 2 columns of working out, might be a good idea. I'm also going to start my list again. U of 1 equals negative 6. What's our common difference? 7. That's good. Okay. So yeah, it's good to, because you might look and think 5, so it's good to just check a few more, just in case you made a little error there. C is 7. Our U of n is 141. Let's first of all work out n first. So what do we know?
How do we work out n?
Yeah, very good point. So we know that this is the U of n, the last term. So we can use the U of n formula, because we know all the other stuff that goes into it, and solve for n. So the U of n formula, yeah it is, this is very formula intense. So this is when you want your formula booklets out. So that is the U of n formula from lesson 1. Feel free to write a little note that that's from lesson 1. And we know all these things except for n. So we can sub in these numbers. U of n is 141. Is U of 1. That's negative 6. Plus, we don't know what n is, so let's leave that as n.
And why is U of n 141?
Oh yeah, because that's the, notice it's the last term in the sequence.
The U of n
term.
wait,
Yeah. Because we want to know what n corresponds with that term. Like what term is it? Is it the 70th term? Is it the 40th term? Or the 31st term? So we're going to solve for n. And we know that d is 7. So now it's an algebra solving kind of problem. So you solve it any way you like. Personally. You could add 6 and then you could divide up to 7, or you could expand first. Either way you'll get the same answer. So I'm going to go with adding 6 first. Equals 7. So you could, as I said, it's not wrong if you expand it first. Then I'm going to divide by 7. So 147 divide by 7. It's going to give us a nice whole number. What's 140 divided by 7? Yeah. 20, yeah, it is 21 overall. Yep. So if it was without calc, I'd think what's 140 over 7? It's 20. So 147 over 7 is 21. I didn't give myself any space over here, by the way. A bit daft. I meant to do 2 columns. But I can do the sum down here. N minus 1. So our n equals 22. Yeah. So I'm just going to separate that off because I kind of need me because of the way I wrote it out. And now here I'm going to work out the sum.
So now we know that there's 22 terms?
Yeah, exactly. So now we know that the n is 22. So now work out the sum of 22. 22. And you can use the nice short version because you know the last term. We were just missing the n. So if you want, if it helps write out the formula, well, you're welcome to do it. N over 2, U of 1 plus U of n. And so we're now going to calculate that, which is 22 over 2. Sometimes you guys keep calculating away, and then I'll just pause this. So you guys just be plugging it into the formula, and I'll slowly do that. Yeah, so the next one, straight up. Okay, so who's got an answer?
11440.
Oh, I got a different one. 1320. I could be wrong, but yep, that's what I got. So let's go with that. 1320. So it's good to practice that what you're doing, just plugging it into the calculator, so you can kind of sort of see what things could potentially go wrong. Okay, let's move on. Those of them were nice, reasonably straight up, just calculate the sum. But the other one where we had to work out n first was a bit trickier. Some more tricky ones. 13 numbers are in arithmetic sequence. The sum of the numbers is 270, so they've told us the sum, so we're probably going to have to solve for something. And the last number, the u of n, is 38. What is the first number? So they want us to solve for something. If you weren't sure where to begin, writing out your list can sometimes be a little bit of inspiration. 30 numbers are in the arithmetic sequence, so n equals 30. The sum of the first 30 numbers is 270. You could write this as 30 instead. The last number, u of n, is 38. What is the first number? So seeing that list might help you think which formula you might want to use. But we don't seem to have any D going on. We do have everything else from a different version. Would you agree the short version of the sum formula? Yeah, it's maybe ideal. So that's what's tricky, is just trying to think, what formula am I even going to use? So I personally like the list because looking at those help me kind of decide which formula to use. This and then this one. You don't need to write the references. I'm finding out which one I need. That's the one. That goes really well with this. Because we know this, we know this, we know this, we need to solve for that. So if we do 270, solving. How do you like to solve? You might want to work out that's 15 first. Then would you agree that you're going to have to divide by 15 and then add 30, subtract 38, sorry? Yeah. We'll do the solving. Do it all in one step if you want, or work it out bit by bit. It's amazing. Do it in one step. U of 1 equals and did you get a negative number?
Yeah.
Yeah, negative something. And 20, yeah. That's it. So yes, thank you. Very good. Thank you, Kiesa.
Yes.
Yes, so that was definitely not. So let's just exclude 270 and divide by 15, and then we should have subtracted 38. Thank you. U of 1. And U of 1 equals negative 20. So you can see how important algebra is. Always good to check, is that all they wanted? What is the first number? Yes, thank goodness, that's all they wanted. Yep, great. Okay, Brian and Melissa. It's kind of getting into applications now anyway. So the very last topic, applications, it's kind of a bit of what we're doing in this lesson anyway. So Brian and Melissa save $50 in the first week of a savings program, then 55 in the second week, 60 in the third, and so on. How much will they save in 10 weeks in total? So if they want to know the total savings, then generally that means the sum. They want the sum of the first 10 weeks of savings. How long will they have to continue saving if their target is to save $5,000? So how long do you get, which thing do they think they want us to find? The D, the U of N, the N? The N, yep, that's right, good. That's a very good point, because that's what's tricky, is like, what are they even asking for? Like, what is this in the formula? How long? Because N is the number of weeks in this particular case. So
But
this.
then what is question?
Yeah, exactly. But do we need to work something out first? So yeah, maybe let's start to generate our list. First of all, like, we know it's arithmetic sequence because this is the topic. But in an exam, you wouldn't realize whether or not it's an arithmetic or geometric until you kind of thought about it a bit. So 50, 55, 60, you probably would pick up that it's an arithmetic sequence. The difference is, yeah, good. The difference is 5. What's our U of 1? 50, yeah. Have they told us the N?
Well, then, why was it 10 weeks? 10 weeks
Oh, yeah.
SN or
Yeah.
SN?
That's a good point, yeah. So for this one, they do tell us n is 10, yeah, that's right. It's almost like there's a part A and a part B, sorry. So I think because I had it as part A and part B before, but then I thought it would give you more page space if I just condense it. So we'll work out this part first. So we do know that n is 10 for that one. And then later on, we're going to have to solve for n, but with a different problem. So we can do the second part later on this side, maybe. Saving in 1st week, so what we're doing first, well, how much would they save in 10 weeks? Yeah, you're totally right. So you're right, so Christy, you were talking about the first one. They want the S of n. Do we know the final term in that one?
Yeah.
No, we don't. It's one that we could work out easily, but still having to add all the time is annoying. So we can use the long version of the formula instead. S of 10. 10 over 2. 2 times u of 1 plus n minus 1. And our d is 5. Again, it goes into the formula. You can go into your calculator just like that.
Wait, why did we use that one this time?
Because we don't know the last term. We could probably work it out pretty easy though. No? Oh, the first part is the sum of 10. So this whole sentence is like, imagine that's part A in the question, and then this is a separate part, part B. So we're just dealing with part A first, you're right. But in part B, we wouldn't know what n was. So then that goes, a little clue is it's a number less than 1,000, just so you know if you're right off. And it'll have units. Did you get 700 and something?
Yeah.
Yeah, 725. And it's the life context, so you can write 725. So it's because they wanted that answer. Like that's part B, for example. Let's put a little circle around it. Then we can do part B on the side or underneath, wherever you like to do it. How long would they have to continue saving? So in that case, that's one Felice was answering. They want to know the n, how many weeks. If their target is to, in total, save $5,000. So what would be our S of n in that case? 5,000, yeah. So if you want to generate another list, if it helps, feel free to do that. U of 1 is still 50, C is still 5. We know the S of n is 5,000. We want to know what the n is. So we're going to have to solve, unfortunately. We don't necessarily know the last term in the sequence either. So we probably have to use the long version and solve for n.
But that's not. So what? That didn't give us the last term? That just gave us the sum.
Yeah, after 10 weeks, yeah, the sum after 10 weeks. And here they're saying, imagine that so obviously, if they say, okay, if we wanted the sum to be 5,000 instead, how many weeks is that going to take? So if this was 5,000 instead, what would our n have to be? So that's going to be a bit trickier to solve. Okay, so let's start to do that. So we know the S of n is 5,000 equals n we don't know, so let's just leave it. N over 2. 2 times u of 1. If you want, you can go straight to writing 100. If you realise, okay, that's easy. Plus n minus 1, because we don't know what n is. And our d is 5. So you get a good mark for just writing that, so don't be scared to write the original formula with everything subbed in, because you get a good mark for doing that. Now you might want to calculate a few things if you haven't already. So 5,000 equals n over 2. 2 times 50 is 100. And then if you expand, you might choose to expand next. Plus 5n minus 5. It's going to make things a bit simpler.
You multiply 2 out?
Yeah, if you want to do that instead, let's do that. That's a good idea. Let's multiply the 2 out as well as collect the like terms all in one set, which will give us 1,000 equals n 95 minus 5n. down a bit.
Where's
Did I do something wrong there?
it's 10,000.
Oh, sorry, yeah. I wrote 500, didn't I? Yeah, so in the above line, I wrote 500. Yeah.
Is it 95 plus 500?
Yes, thank you. Hold on. So we've got 5,000 is here, so therefore that's right, 10,000. And then 95 here, and then plus 5n. What would you do next? Expand is a good idea. You might end up with a quadratic.
Yeah.
Yep. Quadratics are coming back. And solving for a quadratic, we want to kind of
Make it 0.
yeah, exactly.
Just
Set it
subtract
fully for the 0 first. Yeah, yeah, exactly. 0 equals 5n squared plus 95n. Yeah, then subtract 10,000. Pretty awkward one to do by hand. You could divide everything by 5. Divide every single term by 5 might make life a bit easier if you had to do it by hand. If it was with calculator, you could use polysmart now.
Wait, can you show us to do without a calculator?
Yeah, let's do it without a calc. That's fun. I would divide everything by 5. Take out 5 as a common factor. Because they're all multiples of 5. 0 divided by 5 is just 5. 0, sorry. 5n squared divided by 5 is just n squared. What's 95 divided by 5?
9.
Close? Yeah, 100 divided by...
95,
Yeah.
19.
19, yeah. It is 19, yeah. Because 100 divided by 5 is 20. So 95 divided by 5 is 19, one less. And what's 10,000 divided by 5? 2,000, yeah. Think of like 10 divided by 5 is 2. That's still a pretty awkward one. But we could potentially put it in a quadratic formula, if you like. Yeah, running out of space. They're pretty nasty numbers, so I wouldn't be surprised if this would have ended up being a calculator one. You could also try to think, are there two numbers that would multiply to give negative 2,000 and add to give 19? And one would have to be a positive, one would have to be a negative to get negative 2,000 when you multiply them. And so on. It might end up just being a decimal one though. I can just see from here it's a decimal, so that's a bit of an awkward one. Yeah, so quadratic formula. So you could solve, I'll say you could solve using quadratic formula or use polysmart. But you actually get a decimal for this one, so I would assume it's a calculator one. Quadratic formula. Or just use polysmart. And you get a positive and a negative answer. Unfortunately, I only recorded what the positive answer was. So does anyone have polysmart on the calculator? I know 36.2, yep, so 36.2 to 366. What was the other one that was negative? 5.2. So which one would we reject? Yeah, the negative. I forgot to write the negative, didn't I? Very good. So we will reject the negative. 55.2. So we're going to reject the negative and accept the positive. So, and then we just want to write some units. 36.2 weeks. That's not very clear now, is it? I've got to cross it out. N equals negative 55.2. Maybe I'll just put reject. Reject as negative. Yeah, that's a very good point. Yeah, exactly. You would have to, if you had to round up to the nearest week, then you would say 37 weeks. So they would have accepted 37 weeks because it wouldn't be until after 37 weeks that you've saved 5,000.
Why would you round up?
Yeah, if you had to round to the whole week, yeah. So it's actually, they would accept that because they're not requiring you to round to a whole week. You can get 36.2 weeks technically. But if you wrote 36 weeks, that's wrong. Because 36 weeks, they would have saved just under 5,000. So, but 36.2 or writing 37, they would have accepted. It's always safe to have your decimal answer first. Still going on, isn't it? One more?
Yeah,
Many more. The last page is just a recap of formula. That's not too bad. We could even just skip that if you wanted to. We'll do the 2 more examples. Polly's read only, great. Okay, no, we'll do it later. Pretty tough. Okay, so the third term, this is a bit tricky. We've got some ones where they're not telling us the first term. The third term of an arithmetic sequence is 32, and the sixth term is 17. Find the common difference, and then the sum to the first 10 terms. So it's one where we've given us a clue. We need to find D first before we can calculate the sum. Did they tell us the U of 1? No. But they did tell us a third term and a sixth term. So we might be able to make 2 equations and solve them simultaneously. Remember when they tell us 2 different terms and one of them's not the first, we can write 2 equations and do simultaneous equations using our U of n formula. The general U of n formula. So we did one like that in the lesson 1, where we had to come up with the formula for the first term, come up with the formula for the sixth term, solve them as simultaneous equations, and then so on. So the third term is 32, so we can say 32 equals U of 1 we don't know, unfortunately, but we do know if it's a third term, what's our n got to be? 3, yeah. And we don't know the common difference. Remember, when we solve for simultaneous equations in this case, we've got an x and a y, so that's okay. We can just call one equation 32 equals U of 1 plus 2d, and you simplify that. The other equation could be this one. So the second equation using the sixth term. Sixth term is 17 equals U of 1 plus, and it's the sixth term. 17 equals U of 1 plus 5d. So the little clue is, do you think our d is going to be positive or negative? Yeah, how do you know it's negative? Yeah, it's descending. Well done. It's the third term is 32 and the sixth term is 17. So that's a little clue. Our d is going to end up being negative. And then we can solve in polynomial if you want, or do it by hand. So you could solve it by hand if you want. However you like to solve simultaneous equations. I'll let you use polynomial if you want to, because it's good to practice as well. Or you can use elimination.
Multiply 1 by n.
Yeah, or you could eliminate U of 1 by subtracting them. I don't have much space to write and subtract. Subtract, gonna work. So subtract. Oh, so then that's a quick way. Yeah, you could. Then that eliminates D. So then you get 2d minus 5d.
Negative 3d.
Yeah, negative 3d equals
15.
15. Cool. Yep. So d equals?
Negative 5.
Okay. So we've done the first part. We've found the common difference. And now we can then, we know what the d is, we can now find the sum of the first 10 terms. And to find the sum of the first 10 terms, you might also want to know what the U of 1 is. That might be helpful.
Now I have to find U of 1.
Yeah. Or a shortcut, you know the third term? Yeah, you know the third term, so you can just go back. Yeah. That might be faster. Or you
32
could,
plus 5.
or you could just start in into here itself.
So first time is 42.
Probably, yeah. Because you add 5
Yeah.
and add 5, yeah. So the first term is U of 1 equals If you want to show working out for it, you can. So U of 1 is 42. I can't stop myself. Show working out. 32 plus 5 plus 5. Yes. Yes. Yeah, so U of 1 is 42. Because with the third term is 32, so the quick way was just go back by adding 5 instead to the first term. Our D is still the same thing. D equals negative 5. It's the sum of the first 10 terms, so n is 10. They want to know S of n. Do we know the last term? No, we don't. We could work it out pretty easily. Just subtract 5. But they like you to use this fancy formula. So we're using the long version of the sum. So the sum.
Wait, why do we believe in the last term? We're doing the long way because we don't know the last term.
Yeah, we don't know the last term, yeah. If you wanted to work out the last term, you could. But there's a risk you might get the ninth term by mistake. So I'm going to use the long version. 10 over 2. 2 times U of 1 is 10 minus 1. D is negative 5. So then some people don't like to write the negative 5 afterwards. They like to put brackets, negative 5. If you prefer to do that, you can. And we just work out that answer. And it's a big-ish number. No, it's not that big because it's we're going into negatives. So you're going to start to add negatives in. It's a number less than 200. Because the numbers will start to become negative. Yeah, sure thing. So once you get up to the 10th term and so on, like the numbers will be negative. So once you're starting to add the negatives, the sum won't, in total won't be that high.
I got a negative
195, yeah. Yeah, 195. So what could be wrong? Feel free to try it again in your calculator. Because it's a tricky one to put in. So as I said, it's good practice in your calculators.
No, it shouldn't be negative.
And then if you...
I got 195.
Wait, why would it be negative if it's I should have my head.
Because if you get 84 subtract
I thought 195. It could be wrong though. If most people are doing that. Let's see, 42. You can do it manually if you want to check. 42 plus 37 plus 32 plus 27 plus 22 plus 17 plus 12 plus 7 plus 2. Yeah, so most of the numbers are going to be positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're only adding one negative plus negative 3. Yeah, so it's going to be a positive number because most of the numbers in the sequence are positive. It's not till you get to the 10th. Oh, you found the nth term, did you? So if you got negative 3, you found the 10th term, yeah. Yeah, well done. Well picked up on. So if you found the 10th term, if you got negative 3, it's because you found the U of n instead. But they wanted, what did they want? Did they want the sum? Yeah, the sum, yeah. That's a bit of a tough one. Our last example before we're done. The first 3 terms of an arithmetic sequence are this. So yay, we know the D and we know the U of 1. That's helpful. We know those 2 things. Find the 60th term. So they want the U of n, but for n is 60. Find the 60th term. They didn't say find the sum. Just find the 60th term. And hence, so once you've found the 60th term using the U of n formula, hence or otherwise, find the sum of the first 60 terms in the series.
Okay, so then it says find the 60th term. That means u equals 60?
Yeah.
Yeah.
Yeah. So we're just going to calculate the U of n first. And when they say hence or otherwise, means that you could use, once you want to calculate the sum, you could do the short version or you can do the long version. That's why they say hence. You could use your answer to this, because that would give you the U of n.
So we're trying to find the
This is actually a pretty easy one.
60th term. So they're just going to be u n equals u1 plus n.
Yeah, exactly.
So it would still be 60 to un.
Yeah, n is going to be 60, yeah. So find the 60th term first. Find the 60th term first. So now u of 1. 1, you know, d. Is that d? 5. Is 5. N equals 60. I want to know u of n. U of 60. So using our lovely u of n formula. Goes into the calculator just like that, which is lovely. And you get a number that's less than 300. Scroll down a bit. Did anyone get 290 something? 294, yep. So you've got the 60th term, which...
I got 1, 1 and not -1.
Oh, because I did it wrong. Thank you. Exactly, so it's -1. So it's the same answer, as in like the answer is correct. It's a -1. Oh my goodness. So you then now go ahead and find the sum. Well, I just fix the order. So you find the sum using either the short version or the long version.
But we don't know the last term, we know the 60th.
Yeah, so you can use the short
The
version.
60th term is the last term.
Yeah, 60th term you found. So hence that's why they've written hence or otherwise. Because you could...
Didn't figure out what the U of X was.
Yeah,
So isn't that the last time?
yep, it is. Yep, so you can use that in the sum formula as the u of n, which is ideal actually. That's probably what you want to do because it's shorter. N equals u of n. The shrunken u of n. Okay, so now find the sum. If you want to check an answer, feel free to. The little clue is your answer will be between 8,000 and 9,000. I lose it. Did anyone get 8,700 and something?
700 maybe.
Yeah, 8,790. So it's fine if you use the long version because you know all the stuff for that. You could also use the short version because you now know the year of it. So you end up getting 8,790. And I'll just stop it there.